This is problem 6 from homework 2. We're going to solve this differential equation using the integrating factor idea. So first we'll start with when x is between 0 and 10. In that case, p of x would be 1, so the integrating factor would be e to the integral of p of x dx, which in this case would be e to the x. So actually start using this notation, which I've been seeing and I like quite a bit. Call the integrating factor ix equals e to the x. And q of x would be 5. So we know from our integrating factor solution algorithm that the integrating factor e to the x times y equals the integral of q of x, which as we said in this case will be 5, times the integrating factor. So we get y equals 1 over e to the x times the integral of 5e to the x is 5e to the x, and then plus c times e to the negative x. We divided by e to the x everywhere, so these two cancel out, and when x is between 0 and 10, we get y equals 5 plus e to the negative x times c. We'll label this c1. Y of 0 equals 6, so 5 plus 1 times c equals 6, so c equals 1. We'll just write that down. Y of 0 equals 6. 6 equals 5 plus 1 times c1. c1 equals 1. And finally, y equals 5 plus e to the negative x. Alright, now consider the case where x is equal to 10 or greater. Again, we'll use the integrating factor method. In this case, q of x is going to be 1. So we have, again, e to the x. By the way, p of x is still e to the x. So e to the x times y will equal the integral of q of x, which is 1, times e to the x, our integrating factor, dx. So this will give us y equals 1 plus e to the negative x times c2. Now let's scroll up a little bit, scroll down rather. Now we have our IVP because we want to solve for c2, and that IVP is when when x is equal to 10 exactly. Since this should be a continuous solution, it should be equal to the equation right here evaluated at 10. So we could say y of 10 equals 5 plus e to the negative 10. Let me make sure I agree with that. That's what I have in my notes, but Yes. Yes, indeed. So, that will give us y equals 1 plus scratch that. And what that gives us is this evaluated at x equals 10 is equal to that. So we'll write 5 plus e to the negative 10 equals 1 plus e to the negative 10 times c2. And that will give us, solving for c2, 5 minus 1 is 4 plus e to the negative 10 divided by e to the negative 10 becomes or rather 4. Alright, now that tells us y equals 1 plus 4 times e to the 10 plus 1 times e to the negative x. Alright. Now just to put everything together, we'll say y equals the piecewise solution 1 plus 4 times e to the 10 plus 1 times e to the negative x when x is greater than or equal to 10. And y equals, that's not how I want to write that. Let's see, where was I? Yes, this over here. 5 plus e to the negative 10, no. to the negative x when 0 is less than or equal to x, which is less than 10.